Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with a topic hydrogen, its preparation and manufacture. In my last video, I have given a short introduction to the element hydrogen, which is the first member of our periodic table with atomic number 1. Now for any element, if we want to know it, first of all we should understand how it is prepared. Now there are various methods of preparation. The first one is, we know that the formula of water is H2O. So definitely water contains hydrogen. So water being H2O, it has hydrogen and oxygen. So from water we can separate out hydrogen. So different types of metals react with water in different ways depending upon their reactivity. The alkali metals and the alkaline earth metals, they react with cold water also and evolve hydrogen. For example, sodium in the form of its amalgam. Sodium amalgam with water forms sodium hydroxide and hydrogen is evolved. Now we use amalgam because if we are using amalgam, only a very small surface of the metal will be exposed during the reaction, and so the reaction will be slow. So we take the amalgam form of sodium. Now for some other metals like zinc, iron, manganese, we have to take these metals in hot state and they are to be treated with steam or hot water. If this reaction is carried out, here also we see the liberation of hydrogen gas. Like zinc with water will give the oxide of zinc ZNO and hydrogen gas is evolved. Similarly, iron with water, that is here in both the cases with zinc and iron, it should be hot water or steam. Then we get Fe3O4 and hydrogen is liberated. If we have ionic hydrides like sodium hydride or calcium hydride, when they react with water, they also release hydrogen and the respective hydroxides are formed. For example, if we are using sodium hydride, we get sodium hydroxide. If we use calcium hydride, which is also ionic hydride, we get calcium hydroxide along with the liberation of hydrogen gas. Some compounds of carbon like methane can react with steam, and in the presence of some suitable catalyst, they also produce hydrogen along with carbon monoxide production. We have seen that since hydrogen is an integral part of water, we can also produce hydrogen from water by its electrolysis. Means in the presence of electricity, we can break down the molecule and liberate hydrogen. In order to increase the conductivity, we can add some amount of acid or alkali to the tune of 15 to 20%, and then when it is electrolyzed, we see that hydrogen will be liberated. Now in any electrolytic method, we need a cathode and an anode. Here the anode is made up of nickel and the cathode is usually of iron. In order to make the method very fast, to increase the conductivity, we can add some acid. Now see, if we add sulfuric acid, if water has sulfuric acid and we do the electrolysis, we will get H plus and OH minus ions from water. From sulfuric acid, we will get H2SO4 is sulfuric acid, H2SO4. So we have sulfate negative ions and H plus ions here also. So this will liberate SO4, 2 minus and H plus ions. Now H plus ions are cations, they will go to the cathode. Water also will produce H plus and OH minus. So H plus is common for both. That hydrogen ions will be discharged at the cathode. They accept electrons and get converted to hydrogen gas, which is liberated at the cathode. At anode, actually sulfate ions are not discharged. Here sulfate ion is also produced as an anion, but we know that the discharge potential is higher for sulfate ions than that of the OH minus ions. So sulfate ions are not discharged on the anode. So what will be discharged at the anode? OH minus. So OH minus ions, when they go to the anode, they get rid of the electrons and we get water and oxygen. So oxygen will be liberated because sulfate ions having a higher discharge potential, they will not be discharged at the anode. So OH minus, they lose electrons, and finally water molecule and oxygen gas will be liberated at the anode. On the other hand, if we are using some base like potassium hydroxide, so potassium hydroxide is KOH. So from here the ions which will be discharged are K plus and OH minus from potassium hydroxide. Water will produce H plus and OH minus. So these are the 4 ions. That is, OH minus is a common, so actually 3. K plus, H plus and OH minus. OH minus being the only negative ion, that is the anion, it will go to the anode. So at the anode it will give out 4 electrons and finally we get water molecule and oxygen gas getting liberated. At the cathode, hydrogen H plus will be liberated at the cathode. It will accept 2 electrons and hydrogen gas will be given out. So this is the case when we are using base for increasing the conductivity of water. Now from acids, that is usually the diluted acids, we can also get the hydrogen gas. It is done by reacting the acids with metals. But specifically we have an electrochemical series that is based on the reactivity. The metals which are placed above hydrogen in the electrochemical series, they react with diluted acid. So here you see magnesium and HCl. Magnesium will take the place of hydrogen and liberate hydrogen gas, and we get magnesium chloride. Magnesium and HCl, dilute hydrochloric acid, react to give magnesium chloride and hydrogen gas will be liberated. If we take dilute H2SO4 and treat it with zinc, zinc will again displace hydrogen because it is placed above hydrogen in the electrochemical series. It will replace hydrogen, we get zinc sulfate, hydrogen gas will be liberated again. So this is between the metals and dilute acid. So here also we find the liberation of hydrogen gas. Some of the elements like manganese and magnesium, they can react with dilute nitric acid for the evolution of hydrogen. Hydrogen can also be obtained from alkali, that is the bases, soluble bases. There are some amphoteric metals like zinc, aluminum, tin, lead. Amphoteric means they react with acids also as well as with base. So these metals, they can react with boiling sodium hydroxide or potassium hydroxide, and in the process they also liberate hydrogen gas. For example, zinc when treated with sodium hydroxide, we get sodium zincate, Na2ZnO2, and hydrogen gas will be liberated. There is another method which is used for obtaining very pure hydrogen, that is Wienow's method, UYENO, Wienow's method. Here caustic potash, KOH, is treated with scrap aluminum. So when the reaction takes place between caustic potash, KOH and aluminum, we get KaLO2, KaLO2, and hydrogen gas will be evolved here also. In the laboratory, hydrogen can be prepared by the action of dilute sulfuric acid on granular zinc. So this is the reaction of a metal with a dilute acid, which we have already seen. So here when zinc reacts with sulfuric acid, we will get zinc sulfate and hydrogen gas will be liberated. In the manufacturing process, actually we can make hydrogen in a much higher quantity, large quantity. So in manufacture of hydrogen, we have few processes. We will see one by one. One is Lenz process. In this we require steam, and we have to maintain the temperature between 550 to 800 degrees C. At this temperature, steam is passed over hot iron. This reaction is a named reaction. It is known as gassing reaction. Gassing reaction. In this, in the presence of steam, iron will react. We get Fe3O4 and hydrogen gas will be liberated. This is a manufacturing method. Another important manufacturing method is Bosch process. Bosch process. BOSCH. Here first we get water gas. First we make water gas. Water gas is produced by treating steam and hot coke. We take hot coke at around 1000 degrees C and it is treated with steam. So first we get carbon monoxide and hydrogen mixture we are getting. So this is water gas we got. Now this water gas is mixed with steam again. The volume of the steam should be twice its volume of steam. And it is passed over a catalyst. Catalyst is the mixture of ferric oxide and chromium oxide. So here what will happen? Carbon monoxide will get converted to carbon dioxide. Here you see carbon monoxide gets converted to CO2 in the presence of the mixture of ferric oxide and chromium oxide, and hydrogen gas is liberated. So this is also a manufacturing method in which first we are producing water gas, and this water gas is mixed with twice volume of steam, and the catalyst used is a mixture of ferric oxide and chromium oxide. The carbon monoxide part is converted to carbon dioxide and hydrogen gas will be liberated. So this is a very good manufacturing process. So I hope the students who are watching my video, they could understand the preparation methods and especially the manufacturing method of hydrogen. Please subscribe to my channel because I'll try to upload videos regularly. And thanks for watching. Thank you all.